Hello everyone, welcome to RZ Programming. In this video series, we will be discussing a lot in detail about computer network and network security. This is the part 1 of the series and the contents for this video are on the screen. And first, what is the internet? Nowadays, everyone is familiar with the internet, but not everyone knows how it really works or what it is comprised of. The internet can be best defined as a network of networks. That means it connects countless smaller networks like your home Wi-Fi, a university's LAN, or a company's private network into one massive global system. These networks communicate using universal standards, mainly TCP/IP, which we'll be getting on later, which allows any device anyway to connect and exchange data. Unlike a single company's private network, the internet is not owned by anyone. It's managed through collaboration between internet service providers, regional network operators, and organizations like IETF and ICANN that maintain the technical standards and domain name systems. This decentralized nature is what makes the internet both resilient and universal. The internet's role in today's world cannot be overstated. It connects billions of devices and allows instant communication across the globe. Every message, video call, or online purchase relies on this vast system. Businesses operate globally, students learn remotely, and entertainment reaches audiences worldwide through streaming platforms. The internet also powers the Internet of Things, connecting smart home devices, vehicles, and even industrial systems, and supports new technologies like artificial intelligence, which depend heavily on online data and cloud computing. Essentially, the internet is the nervous system of our digital society. Network is the point where individual users and their devices first connect to the internet. It consists of hosts such as laptops, phones, or servers that either send or receive data. These hosts rely on access networks, which are the pathways that connect them to an internet service provider. For example, when you use home Wi-Fi, your router connects your devices to your ISP, or internet service provider, through a broadband or fiber connection. Similarly, your smartphone connects via a 4G or 5G cellular network. Without the network edge, there would be no entry point for users to reach the global internet. And these edge devices come in many forms. They are not just computers or phones. On the personal side, you have laptops, smartphones, wearables that people use daily to access the internet. Then there are smart devices like Alexa or smart TVs, which communicate constantly with cloud servers. Even routers and modems are considered edge devices because they bridge your private network and your internet service provider. In bigger industrial environments, the edge can include sensors and controllers that send data to central systems, part of what we call the industrial Internet of Things. Together, all these devices make the internet feel seamless and accessible everywhere. The network core, on the other hand, is essentially the internet's backbone. It's made up of high-performance routers, switches, and massive fiber optic links that span continents and oceans. When you send a message or stream a video, your data passes through this core as small data packets. Core routers handle packet forwarding and routing. That means they determine the best path for your data to travel from one edge of the network to another. The design of the network core prioritizes reliability and speed, ensuring that even when some paths fail, data can automatically be rerouted through alternative paths. This redundancy is what keeps the internet running smoothly at a global scale. And there are two main ways networks can handle communication. Those are packet switching and circuit switching. In packet switching, data is divided into smaller packets that travel through different paths across the network. Each packet finds its way independently and they are reassembled at the destination. This method is used in the internet because it allows for efficient sharing of network resources among many users. In circuit switching, A dedicated communication path is set up between sender and receiver before transmission begins, just like a phone call on old telephone networks. While it offers consistent performance, it wastes bandwidth when no data is being sent. Packet switching's flexibility and efficiency are what makes it ideal for today's internet traffic. And to summarize, the internet works as a vast system of interconnected networks. At the edge, we find the user, hosts, and access networks, the points where people and devices connect. The core provides the high-speed infrastructure that moves data across the world. And the underlying technology, packet switching, allows all of this to happen efficiently, letting billions of devices share the same global communication space without needing fixed connections. This architecture from edge to core, it's what makes the internet the most powerful and adaptable communication system ever created. And so that's it about the internet and some basic concepts. The next video is already up. You can move on to that to get further ahead. Please like, comment, and subscribe on this video and let me know what you like or don't like. See you in the next one. Thank you.